Hello students, welcome to this video. I'm PBS the tutor. I have another interesting question here coming from coordinate geometry. It's an important topic in mathematics which can even earn you some good marks in the exam. But there are certain things that you need to know, such as calculating the equation of a straight line and the distance of a straight line, which we are going to look at today. So this is a scenario that we have this x or y plane. Okay, we have this x or y plane set up saying find the equation of a line CD and the distance of AB. So to start with, CD, this line, that's the line that we're talking about. Okay, just change the color. This line here is what we are talking about. So how do we find that line? First of all, for line CD, we need to find the gradient. Okay, we do what? We find the gradient. So for line CD, we find the gradient. Gradient is given by, first, before I even go anywhere, let's pick the coordinates for C and D. Coordinate C here is 0,6. I hope you know how to pick coordinates. While D here is 6,0. Alright, so we need D, M, which is a gradient in this case. Alright, so what is our M? M is given by y2 minus y1 over x2 minus x1. So let's come back here. What is our x1? This one here is our x1. This one here is our y1. This one here is our x2. And this one here is our y2. So we are going to get them just like that and just plug them in there. So we have 0 minus 6 over 6 minus 0, which I presume I'll be getting a negative 6 over 6, right? So I'll be getting m equal to negative 6 over 6, and I end up getting my gradient as negative 1. Is this true that it's a negative gradient? Yes, because the line is sloping down. When the line is sloping down, you expect the gradient to be negative. When the line is going up, you expect the gradient to be positive. So we are doing the correct thing. Okay, now that we know the gradient, we are going to find now the equation of a straight line. I love to use this formula for the equation of a straight line because it gives me exactly what I want. Alright, this equation just coming from this. It's coming from this. You can see that they have just made this part here the subject of the formula. The m is multiplying this. See what we have here. So y1 is what? 6. The gradient is negative 1. x1 is 0. We have y minus 6. Here we get just negative x, because negative 1 times 0 is to get a 0. So now the equation is negative x plus 6. This is the equation of our brother line CD. Sense, right? B, we are finding the distance AB. So this is the distance AB. So let us first get the coordinates for AB. A is 6,6 and B is 0, negative 2. Is it true? B is here 0, negative 2 and A is there 6,6. The distance for line AB is given by x2 minus x1 your square plus y2 minus y1 your square. Then you everything under the root. Okay, everything under the root like that. So let us now substitute. All right, so AB is equal to 0 minus 6 square plus negative 2 minus 6. By now we know how to get our x1, x2, y1 and y2. That shouldn't be a problem by now. Then everything under the root. So our AB, all right, we end up having negative 6 squared plus negative 8 squared. Everything under the root, which will just give us 36 and 64. Everything under the root. And we end up having everything under the root, which is what? 100. And we end up having 10 units. It's distance, remember, so it's going to have some units, but we don't have those units, so we just say units. It can be any: kilometers, meters, millimeters, centimeters, and so on. All right, so thank you so much.